Hello, my name is John Lindsay, and this is lab report number 3 for ME 3160. Now, this report is over a lab conducted to analyze the effects of a mesh on air through a duct, air flowing through a duct. A fan was used to force air through a duct, and 4 different meshes were used to impede the flow of the air through this duct. Now, measurements of the pressure and ambient conditions were taken at the experiment, as well as images of each of the meshes with a scale provided as well. Using this information, the calculation of the free flow area, the screen loss coefficient, the work done by the fan, and then being able to calculate and plot the performance curves of the fan were possible. Now specifically, the pressure drop across the mesh, the pressure rise caused by the fan, the dynamic pressure at the outlet of the duct were all collected, as well as ambient conditions and the aforementioned images. Using those images, the values to calculate the free flow area were found, and the rest of these equations were used in varying degrees throughout the rest of the presentation and for the deliverables that come after. These 3 error equations were the only ones that I needed to conduct propagation of errors on, and all other errors were found using the t-student distribution. Now, here I had 4 degrees of freedom when I performed my t-distribution, as I collected 5 values from the images for each of the meshes provided. Now, using these and aforementioned equations, the free flow area was found, and its associated area was also calculated. Now, using the free flow area, this C of S could be found through interpolation through a given graphic that was given in the lab handout. Now, this loss coefficient was found using equation 3, and as you can see, the differences in the values are rather large, especially at the end here. And I am not entirely sure as to why this is. I assume this is due to a breakdown of a assumption made in the uses of the equations, though I am unsure. The associated errors provided, the flow rate is also shown here, and it decreases as the meshes become thicker and harder to move through. And the pressure, this is the pressure drop across the screen, and this was merely a reported value with only 2 degrees of freedom. The associated error is also provided here. Now here we have a plot of the fan performance. I adjusted the given values in the lab handout to Laramie conditions, and I also plotted the experimental differential pressures that were found with the corresponding flow rates. These 2 values are rather similar, showing that the experiment I would call a success, at least in collecting the values. C of S, as it increases with the flow rate, is also shown here, and this depicts obviously as C of S increases, it increases the pressure that is expected, the pressure rise that is expected from the fan. Now, this is very important. As you can see, the C of S increasing, and as it gets to the end, you can see the error that I'm suspecting is taking apart, playing a very major role as this last value becomes astronomical. Finally, we have the work done by the fan as graphed against the pressure difference. This point here would be the optimal use for the fan at about 0.2 meters cubed per second in the flow rate. I left the values in inches of water, but this was only because I thought that the smaller values that one acquired in inches of water would be easier to display in graphical form than in pascals. Thank you for your time. I hope I've covered all the deliverables, and I hope you have a wonderful day.